Yeah, thanks for the intro. So YQ here, founder of AltLayer. So as you know, right, AltLayer, we're providing this rollup as service for different stacks like OP stack, Arbitrum Orbit, and also different ZK stacks, ZK Sync, Polygon, CDK. And beyond that, we're also working closely with ETHDenver, building all different AVSs. And we also have this Wizard AVS service. And basically to provide a decentralized sequencing verification and also fast finality. And today I'm going to present some things basically like this combination to make sure like leveraging some latest AVS we built to basically enhance the existing rollups to bring this rollup from state 0 to state 2. And yeah, of course, first we want to see, so what's stage 0, what's stage 1, stage 2, right, the definition. And before we go to the definition, let's look at, okay, what's the structure or the architecture for these normal rollups. As we all know, right, for rollup, typically there is a single sequencer, no matter for this optimistic rollup or for ZK rollup. And when it receives transactions from these users, it will basically sort of pack this transaction, execute transaction, and pack them into a block. And after that, typically the sequencer itself is just a sort of a conceptual component. In the implementation, it consists of all different components like normal sequencing, and then there are also some batcher. And at the same time, we know, right, for a lot of rollups, they also leverage different DA systems. So the typical either use this the batcher to post these batcher transaction bodies to send to the L1 or to the DAs. And as you can see, right, there's multiple different components: sequencing, execution. At the same time, it also regularly post this state rule hash back to the L1, and also the data bodies to like sort of these L1 or the DA systems. Okay, somehow it doesn't show the show the requirements. Can you double check the slides? But anyway, I can quickly like explain to you. For the stage 0, it's a sort of like we don't really have any specific requirements for the rollup. So that means if you just call the single sequencer, this kind of whatever, this machine to help you to sequence and sort of process the transactions, and regularly if you post a state rule hash to the L1, and then we typically call the stage 0, like sort of fully training wheel rollup. The example is the early days OP Midnight. And basically for the OP Midnight, right, we can see that in the early days, it doesn't have fraud proof. And it only has a single sequencer, process the transactions, and regularly pack the transaction bodies and send to the L1. And at the same time, also regularly the serial hash to the L1. So, but we still call it rollup. Even it's a single sequencer, there's no fraud proof. We can't say that, okay, if something wrong, right, we can just hot the sequencer and redo the transactions. And then for the stage 1, it basically we can see this. Later I will show you the picture of the L2 bit. For stage 1, you can treat that on top of this single sequencer, we will have some proof systems. For example, current OP and also this Arbitrum. Especially Arbitrum, even like 2 or 3 years ago, they were the first one that has like sort of the full-fledged fraud proof system. So for stage 1, you can see that, okay, we will just have this proof system, at least one proof system. And beyond that, they also have some extra requirements. For example, they have the security console if something wrong, right? And we basically can upgrade the rollup with out of 5 different signatures to make sure we can upgrade. Instead of like, it's just like the admin of the contract can immediately upgrade it. And then for stage 2, it's relatively sort of more complex than stage 1, but the point is still about this number of proof systems. Compared to stage 1, there are only one proof system, right? For stage 2, we will have multiple ones. We can have fraud proof system. We can also have ZK proof system. Or later I can show you there's a ZK fraud proof system. Or we can also have the TE proof system. So with in that case, right, even one proof system is is a compromise. For example, due to various reasons, right? The fraud-proof system is compromised. Or like if it's a ZK-proof system, if the sort of the prover having some bugs, and we still have some backup, and then out of like 3 proof system, we can, if we have 2 proof, like they can show that the result is correct, then we can basically follow the majority of these multi-proof systems. And then the next one is like also for the security console, right? We will have some more like sort of signers, just make sure like when we do this upgrade, and also longer during time. It's sort of like 30 days, and then we will just compare to like immediately upgrade the system. We have 30 days to really make sure like everything is correct, and once we upgrade, and then things are fine. And if we look at the current status of the entire Rollup space, right, we can see most of the major general purpose rollups, they are stage 0, and very few are stage 1. Actually, this is the old version, and the new version we can see some stage 2, like sort of protocols. But for all the stage 2 protocols, they are these application rollup, not general purpose rollup. For the general purpose rollup, right now we only have OP and Arbitrum, sort of like in this stage 1. Yeah, somehow this it doesn't show the content, but the point that like basically we have this Arbitrum and also this OP into stage 1. The thing is like they all have one fraud-proof system right now. And if we want to move the stage 1 protocols or the rollup into stage 2, we need to first remove the reliance on the security console as much as possible, or at least we need to have more signers to make sure like the upgrade can get like sort of more checks. And beyond that, definitely we need this kind of multiple proof systems. Apart from this fraud proof system, we may need like ZK proof system and also the TE one. So in that case, right, technically, apart from this normal governance requirement like this security console part, right, technically, if you want to sort of move Rollup from either stage 0, stage 1 to stage 2, and then, as I mentioned, right, we need multiple proof systems. In technical terms, either for fraud proof system, we need bisection fraud proof, or like sort of this ZK proof and all the TE ones. But the cool part, we know that if we really engage with the ZK proof system, it's relatively expensive, right? Even we have like Research 0 or 16 team, they have very fast and efficient proving system, but still relatively it's quite cheap. And then relatively expensive. And then we figure out like, okay, how about like we can combine the ZK proof and also the fraud proof? Is it possible we sort of have the cheap proof system or fraud proof at the same time we can also leverage some ZK techniques to make sure like we can basically generate like some relatively cheap ZK proof system. Then that we call these ZK fraud proof systems. And the cool part, as I just mentioned, right? Instead of we generate all the ZK proof for every few blocks for typical ZK rollups, we can just generate like sort of the ZK proof is something wrong. And for most of the time, we can learn from these fraud proof systems and treat in an optimistic way, right? The system or the sequencer won't really behave maliciously. So in that case, like unless there's something wrong, we generate ZK proof. Otherwise, we just assume everything is working fine. Of course, even we have this ZK fraud proof system, right? There's multiple ways to achieve it. One is like, as you can see, right, the first variant. Basically, we still do this bisection like protocol for this proof like sort of during this challenge period. And so in that case, if there's something wrong, right, if there are challengers and these challenge transactions and we start this bisection protocol, we can basically identify this sort of like this instruction level. At the instruction level, okay, what kind of instruction is doing wrong? And then we can generate a ZK proof for this instruction and put into the L1 Ethereum and to do the verification. So in that case, as you can see, right, we still leverage most of the fraud proof system, but then we generate the ZK proof just for the one instruction. So in that case, we sort of like really save a lot of So in that case, we don't really need to have the full-fledged like sort of a WASM or this instruction execution on the L1. We just need this normal ZK proof verification contract on the L1 to do this proof verification. Okay, the second thing, the first variant is still, we assume like sort of the verification or the proof generation is very costly and takes a long time, right? For example, a few minutes or a few hours. But if like sort of the prover is fast enough, like what we have right now from 16 and this RISC 0, right? We can use this like the second version. So basically, once there's something wrong, the challenger send a challenge, and then we can immediately generate ZK proof for the entire past few blocks. So in that case, the bottleneck is on the prover. The prover need to quickly generate the proof for the past few blocks. But if it's fast enough, that'd be great. Then we don't need to do this bisection protocol, which takes a long time. And then immediately the L1, Ethereum verification contract can do the verification of the ZK proof. Of course, like basically there's some pro and cons, right? For the first version, basically we can save a lot of this proving cost. But for the second version, like we can avoid this lengthy bisection protocol derived from this normal fraud proof. And beyond that, I would say like apart from this normal fraud proof and also ZK proof system, right now this TE is very mature. We are collaborating with our partner Automata and basically generate this TE prover for this optimistic rollup, basically this OP stack. So in that case, you can see there's one more proving system apart from this fraud proof and ZK proof or the ZK fraud proof system. And the sort of diagram is quite similar to the ZK proof generation and also the verification. The biggest difference that TE is much cheaper. You don't need you don't need to wait for a few hours or a few days to generate the proof. And with the TE, you can assume like all the execution within these enclaves can be like sort of no tempered. And in that case, right, we still generate these normal proofs for the T instances, but at the same time, we also have this on-chain verification contract to do the verification for the TE proof. And as I mentioned, right, the cool part, like for AltLayer, is we were not just a rollup as service provider. We are building a lot of these cool and important features and also components to improve these rollups. One thing is basically like we have our different sort of verticals around these AVSs. So we build this Vital for decentralized like sort of verification. We have Mark for decentralized for fast finality and also Squad for decentralized sequencing. So in that case, as you can see, right, we can really enhance the rollups on top of the existing proof system. Of course, like I want to mention about Vital because this is something we already work closely with 16 and RISC 0. So for any stage 0 protocols, like using this OP stack, we can, if you leverage Vital, right, you don't need to change your code base, but immediately you can have this like sort of benefit to basically upgrade your stage 0 to the stage 2 by leveraging this Vital AVS. The idea that with Vital, right, you can easily have multiple proof systems. So you can choose like whether you want TE or ZK fraud proof system. We already implement and embedded these systems into this Vital protocol. So apart from this by default, like for example, fraud proof system you have on the OP stack, now you can further choose like ZK fraud proof or ZK proof if you have enough budget, or the TE proof. So in that case, immediately you can basically enjoy all the benefits from the stage 2 rollup systems. Yeah, that's sort of like all the content we like to share, like how we get our rollups from stage 0 to stage 1, stage 2, right? At the same time, by leveraging like some of the AVS provided by AltLayer, we can help you to really achieve this goal. If you want to know like more like sort of latest progress on AltLayer and also some of our partners, feel free to join this event, probably Friday. And we also have this happy hour with Kaito. You can talk to who about this latest this InfoFi cool stuff. And beyond that, We also having this verifiable agent platform. You can treat it as an extension of the Rollup API system. It's still a no-code platform. You can just visit the website. If you want to click a few buttons, and you can launch your own agent for Twitter posting, whatever, or the DeFi portfolio management, and it's very straightforward. But in the end, right, as I mentioned earlier, we are always building these verifiable systems, either for Rollup AVS and also these agents. So that's all the stuff from me. Thanks for your time, and just feel free to reach out to me for any questions on these Rollup and also these verification systems. Thank you.